All right, today in geometry, we're going to look at section 8.2, properties of parallelograms. So let's recall what a quadrilateral is. Remember, a quadrilateral is a polygon with 4 sides. A parallelogram. A parallelogram is a quadrilateral with 2 pairs of parallel sides. And then we have some theorems involving the properties of parallelograms. Our very first theorem says that if a quadrilateral is a parallelogram, then its opposite sides are congruent. In this picture, we would have AB parallel to DC. Therefore, AB is congruent to DC. And if AD is parallel to BC, therefore AD is congruent to BC. So if a quadrilateral is a parallelogram, which means that its opposite sides are parallel, then its opposite sides are also congruent. We have another theorem that says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So then here we could say that angle A is congruent to angle C, and angle B is congruent to angle D. We have another theorem that says if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Remember, supplementary means adds together to equal 180. Consecutive means one right after the other. So we would have several here. We could say the measure of angle A plus the measure of angle B is equal to 180 degrees. Then we could also say the measure of angle B plus the measure of angle C is equal to 180 degrees. The measure of angle C plus the measure of angle D is equal to 180 degrees. And the measure of angle D plus the measure of angle A is equal to 180 degrees. So we have 4 different options there. Okay, one more theorem to go. So the next theorem tells me that if a quadrilateral is a parallelogram, then its diagonals bisect each other. Remember that bisect means cuts it in half. So I could say that this side is congruent to this side. So I could say that AX is congruent to CX. But then I could also say that DX is congruent to BX. So now we're going to work some problems using those theorems. So the very first one, it says find each side measure of parallelogram JKLM. So we know that it's a parallelogram, so we know that opposite sides are parallel, which means opposite sides are congruent, and opposite angles are congruent, and consecutive angles are supplementary. So we look at this picture and they give us the side lengths. So we know that JK is congruent to ML, therefore they are equal. So 12 plus X is equal to 2X. We want to solve this for X. So subtract X from both sides. So then I get 12 equals X. But it asked us to find the side measure, so I need to plug that back in. So if I plug it in, 2 times 12, I would get JK equal to 24 and ML equal to 24 because I know that those two are congruent. So those are the first two. And I also know that segment JM is congruent to segment KL, so I can set those equal to each other. So 3y minus 7 equals y plus 13. Again, I want to get all of my y's on the same side, so I'm going to subtract that y over. So now I have 2y minus 7 equals 13. Add 7 to both sides, so I get 2y equals 20. Divide by 2, y equals 10. So now I need to plug that in. So if I did here, 10 plus 13. And it doesn't matter which side I plug it into, JM or KL, they're both going to be the same. So then I would say that JM is equal to 23. And KL is also equal to 23. So let's try some more. So number 2 says find each measure of the interior angles of parallelogram PQRS. So I need to decide if I'm going to use the theorem that states that the opposite angles are congruent or that consecutive angles are supplementary. I see that I have angle P and angle R, which both have x's. Q and S both have Y's, so we're going to be using the opposite angles are congruent. So we know that angle P is congruent to angle R, and angle Q is congruent to angle S. So we're going to set their measures equal. So 4x minus 5 equals 3x plus 15. All of our x's on the same side, so when I subtract 3x, I get x minus 5 equals 15. Add 5, I get x equals 20. But again, it asked me to find each measure, so I need to plug that back in. So if I plug 20 in, again, it doesn't matter if I plug it into P or Q. If I plug it in up here, 4 times 20 minus 5. So I get the measure of angle P is equal to 75 degrees. Then the measure of angle R is also equal to 75 degrees. So now I want to do angle Q and angle S. So 8y minus 7 equals 7y plus 7. Subtract 7y from both sides. Then I have y minus 7 equals 7. Add 7, I get y equals 14. Again, I need to plug that in. It doesn't matter which one I plug it into. If I plug it in down here for S, 7 times 14, all of that plus 7. So then I get the measure of angle S is equal to 105 degrees. And the measure of angle Q is also equal to 105 degrees. Remember, instead of doing, once I found the first one, measure of angle P, I could have then said the measure of angle Q is equal to 180 minus 75, since the two consecutive would have to be supplementary. So once I found that first angle, I had options to find the second angle. All right, let's go to the last page. Again, find each measure of the interior angles of parallelogram DEFG. So they give me angle E and angle F. These are not opposite, but they are consecutive, and I know that the measure of angle E plus the measure of angle F is 180 degrees because I have a theorem that tells me that consecutive angles of a parallelogram are supplementary. So here I would say 5x plus 3 plus 6x plus 1 is equal to 180 degrees. Combine like terms, so 5x plus 6x gets me 11x. 3 plus 1 gets me 4, so plus 4 equals 180. Subtract 4 from both sides, so I get 11x equals 176. Divide by 11, I would get the x equals 16. It asked me to find the measure of each interior angle. Okay, so plug 16 into both of these. Remember, these are not going to be the same, so I would find that the measure of angle E is equal to 5 times 16 and then add 3. So 5 times 16 is 80. 80 plus 3, 83 degrees. The measure of angle F, 6 times 16 is 96. 96 plus 1, 97 degrees. And again, those two together should equal 180, which they do. Next example, number 4. Find each measure of the diagonal of parallelogram UVXY. Remember, we have that theorem that tells me that the diagonals bisect each other. So that means that UA and AX are congruent, YA and VA are congruent. They tell me that UA is 3x minus 5, so 3x minus 5 equals AX, 2x plus 7. Subtract 2x from both sides, then I get x minus 5 equals 7. Add 5, I get x equals 12. But again, I need to plug that back in. So if I plug that in, it doesn't matter which one I plug it into. So if I plug it into AU, then I have 3 times 12 minus 5. So AU, 3 times 12, 36. 36 minus 5 is 31. So then that means that AX is also 31, but they asked me for the measure of the diagonal. So UX is 31 plus 31, which is 62. So there's the first diagonal. So now I need to do YA and VA. So 5y plus 8 is equal to 6y minus 2. Subtract 5y from both sides, so I get 8 equals y minus 2. Add 2, so I get y is equal to 10. So let's see, plug that in. AY is going to be 5 times 10 plus 8. So 5 times 10 is 50. 50 plus 8 is 58. So AY is 58, and that means that AV is also 58. But it asks for the diagonal, so YV is the entire diagonal. So 58 plus 58 is 116. All right. Last thing that we need to know about a parallelogram. It says if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. Okay? So we have one diagonal drawn here. So then I could say that triangle ABD is congruent to triangle CDB. Because remember that opposite angles are congruent. So this is the same as this. So ABD is congruent to CDB. So these two would be the same. This one would be the same. I can say that the measure of angle ABD is congruent to the measure of angle CDB. The measure of angle ADB is congruent to the measure of angle CBD. And then in this little chart here, I put everything that we need to know about parallelograms. So just to recap, a parallelogram is a quadrilateral that has two sets of opposite sides that are parallel. It also has two sets of opposite sides that are congruent. It has opposite angles congruent. It has consecutive angles supplementary to each other. The diagonals bisect each other, and the diagonals form two congruent triangles. Those are all the properties of a parallelogram that we must memorize. All right, so our homework for today is worksheet 8.2, doing everything that we just did here using all of those theorems.